Today we are starting with new chapter, chapter number 5, Introduction to Euclid's Geometry. Here, as by the name of the chapter, Euclid's Geometry, we will start. So you can see that Euclid is a Greek mathematician, and in geometry we can further divide it into two parts. First is geo, second is metry. Now geo here means earth and metry here means to measure. So Euclid, a Greek mathematician, assumed certain properties which were not to be proved. These assumptions are actually obvious universal truths. These properties were divided into two parts, axioms and postulates. Now, axiom is used for the assumptions in any field in science. Postulate is used for the assumptions that were specific to geometry. Now both of them have one small difference. You can see here that axiom can be used in any field of science and postulate is specific to geometry. So please see it carefully and learn it carefully. They both have a difference. They both are not same. Now Euclid's give 7 axioms to us and 5 postulates to us. First is Euclid's 7 axiom. Now axiom number 1 is things which are equal to the same thing are equal to one another. For example, you can see here if A is equals to B and C is equals to B, then what we can conclude that A is equals to C. Here things which are equal to same thing, that means A and C both are equal to same thing, that is B, and so we can say that A and C are also equal. Now come to second axiom, that is if equals are added to equals, the wholes are equal. For example, if A is equals to B and if we add C on both the sides of equation number 1, then what we'll get? A plus C is equals to B plus C. So you can see that equal thing, if we are adding on both the side, then also it is coming equal. Then come to axiom number 3, that is if equals are subtracted from equals, the remainders are equal. For example, if A is equals to B, okay, and if we subtract C from both the sides of equation number 2, then what we are getting? A minus C is equals to B minus C. Here also you can see that same things we are subtracting from the equal thing and we are getting the answer equal. Now axiom number 4 is things which coincide with one another are equal to one another. So you can see in the example that there are two lines, one is AB and next is CD. Both the lines are of 2 centimeter. As they are same means they will coincide, so they are equal to. Now axiom number 5 is the whole is greater than the part. In this example you can see that if A is equals to B plus C, now if we take it separately, that means you can see that we can say that A is greater than B or A is greater than C. So it is proved that whole is greater than the part. Then come to axiom number 6, that is things which are double of the same things are equal to one another. Here also if A is equals to B and if we multiply 2 on both the sides of equation number 3, or you can say that if we double both the sides, then it will become as 2A is equals to 2B. After doubling also, equation is still equal. Then axiom number 7, things which are halves of the same things are equal to one another. In this here also an example, that is if A is equals to B and if we multiply half on both the sides of equation number 4, then we'll get as half into A is equals to half into B. Okay, now you can see that we have done half of the both the sides of equation number 4. Then also we are getting our equation as equal. So these were the axioms. Now come to postulates. Postulates, here 5 postulates are given by Euclid. So postulate number 1 is a straight line may be drawn from any one point to any other point. In this you can see in the example I have drawn the figure. A point is there, that is A I am considering. Okay, now from here, from A point we have drawn 2 lines, that is AB and AC. Similarly we can draw it more. Now postulate number 2 is a terminated line can be produced indefinitely. Now again in example you can see that AB is the terminated line. That means from A also line is being terminated and from B also line is being terminated. Still we can exclude it. Sorry, not exclude, we can extend it. Okay, extend from A also and extend from B also. Then come to postulate number 3. Postulate number 3 is a circle can be drawn with any center and with any radius. You can see I have drawn a circle with 2 of the different centers and with another with different radius. Now postulate number 4 is all right angles are equal to one another. You can see in the diagram that angle ABC is equals to angle DEF is equals to 90 degree. That means both of them are equal, no matter what is the length of AB or what is the length of DE. Similarly, the BC and EF also not matter in this. Now postulate number 5 is if a straight line falling on 2 straight lines makes the interior angles on the same side of it. Now here in the diagram you can see that a straight line, that means PQ, that is being followed on AB and CD, and you can see that because of that 4 angles is being formed. One is angle APQ, next is angle BPQ, then is angle CQP, and then is angle DQP. Or you can say angle 1, angle 2, angle 3 and angle 4 are being formed. Now we'll continue with our postulate only. What it says that same side of it make it taken together less than 2 right angles, then the 2 straight lines if produced indefinitely, means if this AB and CD, if we produce from A and C, then they will meet on that side on which the sum of angle is coming less than 2 right angles. You can see that angle 1 plus angle 2 is coming less than 90 degree. So that means if we produce A and C from AB and CD, then they will meet at point. But if we extend from B and D of AB and CD, then they will not meet. Okay. Now, on the basis of these axioms and postulates, we will be doing some examples. Now, before that, let me tell you why to study these axioms and postulates. Because as we have already learned about point, line segment, surface and so on in our previous classes, and we have defined them also. But in their definition, there are some terms which are still undefined. For example, a point. If we define a point, it is a point is that which has no part. Here, part is still undefined. Similarly, if we define line, that is a line is breadthless length. Again, length is undefined. That's why Euclid gave axiom and postulates which are universal, which are considered to be obvious universal truth, and which needs no proof. Now come to example number 1. If A, B and C are 3 points on a line and B lies between A and C, then prove that AB plus BC is equals to AC. Here you can see the figure given in the question. Now according to that, we can say that AC is equals to AB plus BC. Why? Because by axiom number 4, that is, things which coincide with one another are equal to one another. Now you can see that AC coincide with AB plus BC. Then come to next example, that is example number 2, that is, prove that an equilateral triangle can be constructed on any given line segment. Now according to this, what I have done, I have taken AB of 4 centimeter. Okay, now and consider it as figure number 1. Now in figure number 2, I have taken A as center and AB as radius, and then I have drawn a circle. Okay, then after that I have taken B as center, BA as radius, then I have drawn another circle. Now both the arcs of the circle intersect at one common point, and I have named it as C. That is our figure number 2. Now by postulate number 3, I have drawn the figure number 2, which says a circle can be drawn with any center and with any radius. Now come to figure number 3. After drawing these arcs of the circles, we have got a point C. So just draw AC and BC. Now we can see from these 3 figures that AB is equals to AC, because whatever arc I have marked through A, I have taken the length equal to AB. So that means AB equals to AC and named it as equation number 1. Similarly with from B also, so we got BA is equals to BC and named it equation number 2. So from equation number 1 and 2, we can say that AB is equals to AC is equals to BC. This again we can conclude from Euclid's axiom number 1, that is, things which are equal to same thing are equal to one another. So on basis of these postulates and axioms, and on the basis of these 2 examples, you can solve some questions from the exercise, that is question number 1, question number 4, question number 6, and then you can take